Good day everyone. So this time I will discuss to you about what is Warshall algorithm.
What is Warshall algorithm? It is used for computing the transitive closure of a directed graph. Directed graph have edges with direction, and an undirected graph have edges that do not have a direction. There are two methods in solving Warshall algorithm: the adjacency matrix and Boolean sum. In adjacency matrix, the connection matrix, it is also a matrix with rows and columns labeled by graph's vertices. 1 if the G has a directed path and 0 otherwise. For a simple graph with no self-loops, the adjacency matrix must have zeros on the diagonal. When we say self-loops, it is an edge of graphs which starts and ends with the same vertex. This is a form of adjacency matrix. For the Boolean sum, it is the second method to solve the Warshall algorithm by using row by column. There are two rules in Boolean sum. Rule number 1. If an element in row I and column j is 1 in r to the power of k minus 1, it remains 1 in r to the power of k. And rule number 2, if an element in row I and column j is 0 in r k minus 1, it has to be changed to I in r to the power of k if and only if the element in its row I and column k and the element in its column j and row k are both 1s in r k minus 1. So this is now the form. So now I have here an example to use these two methods. As you can see in diagram, there are 5 vertices. V sub 1 is directed path to V sub 2, and V sub 1 is directed path to V sub 3, and V sub 1 is directed path to V sub 4, and V sub 2 is directed path to V sub 5, V sub 1, and V sub 2 is directed path to V sub 5, and V sub 3 is directed path to V sub 4, and V sub 4 is directed path to V sub 2, and V sub 5 is directed path to V sub 4. So students, listen up. So these are the vertices having the directed path. Is there a possible that vertices can direct path to itself, or vertices V sub 2 can direct path to V sub 4? Well, the answer is yes, by listing the vertices having a new path. So now I will show to you the vertices, the list of vertices having a new path. So these are the vertices having the new path. V sub 1 is directed path to V sub 1, V sub 1 is directed path to V sub 5, and V sub 2 is directed path to V sub 2, and V sub 2 is directed path to V sub 3, and V sub 2 is directed path to V sub 4, and V sub 3 is directed path to V sub 1, and V sub 3 is directed path to V sub 2, and V sub 3 is directed path to itself, and V sub 3 is directed path to V sub 4, and V sub 4 is directed path to V sub 1, and V sub 4 is directed path to V sub 3, and V sub 4 is directed path to itself, and V sub 4 is directed path to V sub 5, and V sub 5 is directed path to V sub 1, and V sub 5 is directed path to V sub 2, and V sub 5 is directed path to V sub 3, and V sub 5 is directed path to itself. So this is the adjacency matrix to get the transitive closure. And now let's proceed to the next method, which is the Boolean sum. We will use the two rules in Boolean sum. in r to the power of 0 equals 1 reflect the existence of path with no intermediate vertices. In r to the power of 0 is just the adjacency matrix, so the highlighted part are for the r to the power of 1. So highlighting the row and column are used for getting r to the power of 1. In r to the power of 1, 1 is reflect the existence of path with intermediate vertices number in the row of v sub 2, which are v sub 2 to v sub 2, and v sub 2 to v sub 3, and v sub 2 to v sub 4. Highlight, row, and column are used for getting R2. In R2, 1 is reflect the existence of paths with intermediate vertices from the row of v sub 1 and v sub 4. In v sub 1, there are two new paths which are v sub 1 to v sub 1 and v sub 5. And v sub 4, there are also four new paths which are v sub 1 to v sub 4, and v sub 3 to v sub 4, and v sub 4 to v sub 4, and v sub 4 to v sub 5. So again, highlight the third row and column to get the R3. In R3, the same of R2 matrix because there is no vertex at all. In R4, there are four vertices in row v sub 5, which are v sub 1 to v sub 5, v sub 2 to v sub 5, and v sub 3 to v sub 4, and last is v sub 5 to v sub 5. Getting the R5, so highlight the row of v sub 5 and the column of v sub 5. In R to the power 5, new path from the vertex and row v sub 3, which are v sub 3 to v sub 1, and v sub 3 to v sub 2, and v sub 3 to v sub 3, and v sub 3 to v sub 4. So the matrix of R5 is called the transitive closure. Transitive closure, the vertices can reach or connect the other vertices or by itself. So that's all. Thank you.